When we look at the types of services and applications that we consume today as users and as businesses, it looks very different to, 10, 12 years ago. The landscape is evolving every day, and it's really evolving at a rate that humans are finding it very difficult to keep up with. So what we need to do here is we need to be able to work and evolve with these changes at machine speed.
How is this technology changing the landscape and helping companies to protect themselves against these risks?
Your hypershield will never really actually have to ever go down. It's probably one of our most fundamental shifts within Cisco for the last, I would say in the history of our organization within the cybersecurity space.
Welcome to ITWeb Business TV. I'm Tamsin MacKay, and today we're interviewing Cisco to find out more about Cisco Hypershield and how it is designed to protect the business in the time of great threats and vulnerabilities. It is time to reimagine security in the age of AI. And I'm here with an expert in cybersecurity from Cisco who's about to tell us a little bit more about what the company is doing to protect the data center and the business. Welcome.
Thank you so much, Tamsin. Thanks for having me. So just to introduce myself a little bit, my name is Nabeel Rajab. I'm a technical solutions architect at Cisco. I'm one of the cybersecurity leads in our region in South Africa. I've been at Cisco for around about 8 years now in different roles and across different business units and across different regions as well.
So let's set the scene and talk a little bit about AI and how this is impacting security and the data center. Can you just paint us a picture of the landscape right now?
Yeah. So as we all know, the world has drastically evolved in the last, I would say, 10 years, specifically in the area of, applications. When we look at the types of services and applications that we consume today as users and as businesses, it looks very different to, 10, 12 years ago. And that is because, we've exponentially, evolved not just the way we consume applications, but how we host them, and how we run those applications. Traditionally, we'd have, very siloed data centers, private data centers that organizations used to own themselves and run themselves. And with the explosion of public cloud, these hyperscalers, which we refer to them today, we have our applications following suit. They are distributed, they are hyper distributed, we refer to today, across, very small components all over the globe. If you look at some applications like Facebook, or if you look at an application locally like Takealot, that might be hosted on, a private cloud, it might be hosted in a public cloud. All you see as the end user is an application on your phone or a website that you can access those services through. However, in the back end, there are hundreds of thousands, maybe even millions of tiny little components that make up that application. And in this hyper-distributed world, we're seeing certain trends. One of the trends that we're seeing is the inability for us to have good visibility into these applications, into these services, into these workloads and environments, because of the nature of them being so distributed and so sporadic. Again, going back to how we would potentially protect some of those environments, we'd funnel everything through central areas. And now, because of this, this exponential growth of not just the data centers, but the applications itself, it's very hard to sort of contain those applications and understand what's happening within those applications. So these are some of the things and some of the areas that we look at Cisco, in order to, look at how we develop solutions and products around the space.
Yeah, so how is AI directly impacting this? What are some of the implications of that technology on the situation you've just described?
That's a great question, because if we see the exponential growth of data centers and how we're hosting applications, you add on top of that this explosion of AI tools and services, and it just it takes it to a whole new level. We are looking at the change in public and private data centers, because of the resources required for AI, we're looking at magnitudes of growth in this area. So the way we've developed and built data centers up until today is, even though they are hyperscalers, we're not prepared for the next level, for the next step of the evolution of all the resources that these AI applications and tools actually require. These are huge implications on how we build and run data centers today.
Yeah, which actually kind of takes me to my next question. All of this introduces risk. What are some of the key risks that companies need to be aware of?
AI is all about the data, right? You don't have good AI if you don't have good data. So we have to look at how we store that data, how we filter through that data, how we work with that data, and how we use that data to inform our decisions and some of the tools that we get out of AI systems. And on top of that, if we look at the compute resources that these AI systems require, there's multiple layers or multiple levels of let's say protection that you would need to make sure that this isn't used in a malicious way. We can understand what's happening from within these environments. So we are, let's say, we reduce the risk of attack and malicious exploits. Now, it is one thing to understand how heavily scaled these systems need to be, and now we build on top of the fact that these are very, very distributed environments, and now the risk and the challenges posed by both sides of the question of the equation is really plays into a large challenge for organizations.
Okay, and what is the knock-on effect of that? So how does this directly impact the organization if they don't put protections in place?
That's a very good question. If you look at some of the exploits that we've seen today, some of the incidents, if you think about, I think it was in Asia somewhere where there was a deep fake that was generated of, one of the execs to order a payment, and they literally created an exact replica on video of this exec. There are lots of different ways that bad actors are now, perpetrating either, ways to socially engineer certain situations, or even just to access systems and access what we refer to as the crown jewels of an organization, right? The financial records, the credit card information, the user information. So there are heavy knock-on effects, and bad actors are now using AI, to really help them in their causes to carry out these attacks.
Okay, which brings us very neatly to Cisco Hypershield. How is this technology changing the landscape and helping companies to protect themselves against these risks?
So Hypershield it's probably one of our most fundamental shifts within Cisco for the last, I would say in the history of our organization within the cybersecurity space. We've really tried to reimagine how we do security in the data center and for the future, because we understand that the landscape is evolving every day, and it's really evolving at a rate that humans are finding it very difficult to keep up with. So what we need to do here is we need to be able to work and evolve with these changes at machine speed. So what we've done is we've created a cybersecurity platform that is built on AI, natively on AI, that allows us to understand the environment better, be able to scale much quicker, and be able to enforce not just at single points, funnel back to centralized positions within the environment, but it's sort of a fabric. It's distributed, hyper-distributed. The same way that we have these hyper-distributed data centers and applications, we want to reimagine security in a hyper-distributed environment. And so the Hypershield solution is that distributed solution.
How does this technology work and do what it's supposed to do?
So Hypershield really works on a few fundamentals. And one of those fundamentals is that we want to embed the capability to see very deep into applications themselves, even into operating systems, all the way down to the kernel, and everything from that up out of the application to the network and across anything within the environment that might be able to either carry out a task or run a specific workload or even transmit network traffic. So we really don't want to leave anything, no stone unturned in order to understand, firstly, what's happening in the environment. And where the AI now kicks in is it starts to baseline what the behavior of that application or let's say that environment needs to look like. And over time, it will learn what is acceptable and what is not acceptable and assist your security analysts, your data center engineers, all the teams that are responsible for these applications, multiple teams that are responsible for these applications, in guiding them, what might be changing and whether it is acceptable for those changes to occur or not. Now, one of the key things that we must remember is that there's always a fine balance between protection and availability, or let's say performance for an application. And traditionally, if we'd see an attack being perpetrated, the older ways of doing security within an environment like a data center would be to lock down everything, and that reduces that application or that service. It reduces the availability of that service. Now, what happens is, people can't access that site or their bank accounts or whatever that application might be. And that is very restrictive. So what we want to do with Hypershield is we want to firstly understand the behavior, but then slowly start to, protect, let's say, anomalies or unusual behavior and isolate that without impacting the entire environment or the entire system. And that's sort of where we're going with how we are trying to approach security using Hypershield.
So it's like business as usual, but with the unusual protection of Cisco Hypershield.
Exactly.
Okay. So what technology underpins this solution?
The technology that we've built this on, as I mentioned, it's built natively with AI in mind. It is completely cloud native, so it is consumed as a SaaS service from anywhere in the world. You can access the system, and it's built on very small hyper-distributed components, and that is all basically software. We look at using things like little agents that are deployed within operating systems, VMs or virtualized appliances that can understand a workload, understand an entire system, and all the way into hardware themselves. Things like data processing units, things like even embedded within smart switches, for example. The vision is for us to be able to see everything and be able to make those decisions. So it's really built on a lot of very small hyper-distributed components and managed centrally, on top of the AI platform.
So you've mentioned some of the benefits to the business already, but are there any other benefits or value adds that this technology brings to the business?
We want to be able to firstly get that visibility, but we want to be able to make sure that, it's easy to deploy, it's very manageable, and it really assists rather than hinder teams, right? So we're making it extremely easy to adopt. And it's because of the software-based approach of being able to run and deploy the system that it's actually, firstly, very, very easily deployable. It can be scaled because of the fact that we deploy this centrally and manage it centrally through a cloud environment. And again, because it's very lightweight in terms of the components, it really saves on having to, let's say, invest in very heavy and slow physical infrastructure. So, when you think about change, we used to deploy these large, very heavy hardware-based appliances, and that was very expensive. And being able to change that or being able to upgrade that was very slow. So really, in terms of time, we're seeing huge reduction in costs, for example, to deploy and maintain this type of system.
Yeah, so it's massive cost savings while giving you extra security, which is in itself a cost saving.
Exactly.
So beyond some of the use cases you've already mentioned, are there any specific use cases that you would like to highlight now that really showcase how this technology works?
It's all about the use case, right, Tamsin? So, if we've identified two primary use cases that that we think are very important for these types of environments. The one is automated segmentation. One of the challenges with organizations is that they don't really have the visibility into what workloads are talking to each other. So it's a little bit easier to understand outside in when users or even administrators are accessing certain systems. You can understand what that flow looks like. A user opens up an app, that app talks to a back-end service. It might be a website, a web front end, and then that talks to back-end services as well. So that is a little bit easier to track. What becomes very difficult is now that, as we mentioned previously, we have these hyper-distributed applications that are located across multiple data centers across the globe potentially. Those workloads are all talking to each other. It's very difficult to be able to understand what that looks like, not just between, for example, server to server, but also within the application, within a server, services running on a specific server, talking to each other. That is a little bit more difficult to understand. And because we don't understand it so well, or we don't have a great visibility on that, it's very hard to protect. You can only protect what you can see. So what we're doing with automated segmentation with Hypershield is, firstly, we are understanding exactly what is happening within that application or that environment. We have that depth of visibility now, and we can baseline that using the AI that I previously mentioned within the tool. Once we've baselined that, we can now start to understand, or at least start to enforce, what should be talking to each other and what doesn't necessarily need to talk between different workloads or between different services running on a server. Once we have that type of visibility and enforcement, we have a reduced attack surface, because now we understand exactly what is happening, what should happen, and we have a baseline for behavioral anomalies.
Okay, that's amazing. So that was one use case. Do you have any others that you want to share?
Yeah, so there are a couple of other use cases that I think would be very interesting. The other use case covers distributed exploit protection. So when we talk about exploits, we're talking about specific vulnerabilities that might be present in different technologies. We have, all kinds of switches, firewalls, routers out there in the market, right, in industry. And, these are all built on software. And the way we actually roll out features and functionality in the industry today is on a very quick, iterative, continuous basis. And what happens there is we leave gaps for these vulnerabilities, and people then find out about them, and bad actors then, they will act on them. They will look for a flaw in the software or the code, and they will take advantage of that. And then we refer to these as vulnerabilities. And when a vulnerability is actually used in, to carry out a bad action for an organization, that then is termed an exploit, right, of that vulnerability. Now, we see these vulnerabilities and exploits all the time. Dozens of them come out every day, that are published. And how do we protect against them? We then go and research. We find out where that flaw is. We plug that flaw with a new patch or a new version of the software. We roll that out after much testing, and it goes through the whole software lifecycle, the whole software adoption lifecycle and rollout lifecycle. And this can take months. And with dozens of these exploits and vulnerabilities being published every day, that's just simply too long. Because by the time we actually release a patch or a fix, that exploit has been out there in the wild, and people are taking advantage of this, quite constantly and quite regularly. So what we needed to do is we needed to reduce the time that we can take to fixing that, or at least in a way be able to isolate and segment that specific vulnerability until we can reach a point where we can fix that or patch that flaw. And that's what we're doing with Hypershield in terms of exploit protection. So this is completely distributed, as I mentioned. It will happen as a fabric across the entire environment. And what we would do is we would receive feeds from all over the industry, from our own Talos agency, which is the largest private threat intelligence agency in the world, right? Apart from obviously governments and public agencies out there, we have hundreds of researchers looking at these threats and at these exploits. They do the threat intel and they form a database of all the different things that are out there. And they provide that back to all of our different solutions, not just to Hypershield. Any other Cisco security solution will get these feeds. But what Hypershield does, it will pull in or ingest these feeds and will look at other third-party feeds as well. So anything that's out there that could potentially be a vulnerability within your environment, Hypershield will learn of, and then it will start to look for these vulnerabilities, whether they are on the network or whether they're in software operating systems as well. And because we have very deep visibility using some of the technologies that Hypershield is built on, eBPF for one, we can actually see down into the kernel of an operating system itself. So we can start segmenting that out at the kernel layer, within these workloads or within these environments, and then buy us time so that these vulnerabilities and flaws are actually patched. So that's another one of those very interesting use cases, and how it's fundamentally different from anything we've done before with Hypershield. Another thing that we're doing is a very unobtrusive way of upgrading the system. It's almost upgrading on the fly without taking down these systems, right? When you do an upgrade of an operating system or a new firmware change for any networking equipment or server, that you would usually take that device down completely. What we're doing with Hypershield is we actually created 2 data planes to exist on. One data plane is us operating as normal. You have your traffic flows, you have your workloads, that are actually talking to each other across these distributed environments. And that's all well and good. Well, what happens during an upgrade is that data plane would go down completely. So what we're doing is we're saying, why don't we create a new data plane where we can make those changes, do those upgrades, apply new policies even, and see how that reacts to the entire system. And if everything is well, then we drop the initial data plane while your application is still running on what we refer to as the shadow data plane, and everything keeps going while the system gets upgraded. So your Hypershield will never really actually have to ever go down in order for us to get to a new version, to get to a new patch for any new features and functionality. It's always up and running. So those are the 2 other, I think, very interesting use cases that have been built around Hypershield.
I agree. So this is clearly Cisco's next generation of security, right?
It really is.
So do you have any final thoughts that you'd like to share about the tech and its value to the business?
Yeah, so I think one thing important to take away from this is that bad actors have been using AI to carry out their attacks. And what I really believe now is that we have the tools in place to own that again, to take back, the AI space in order to protect against, these malicious actors. Because, we, at the end of the day, as human beings, can only achieve so much. We only have 24 hours in a day. But what we need to do is we need to operate at machine scale, and that's what AI is actually allowing us to do. It's allowing us to operate at machine speed and machine scale, augmenting our ability to set intention, to set what we would like for our business or our organization, and allow it to do what it needs to do. For the longest time, I think we've not really owned that space because, like I said, there are exploits and vulnerabilities out there that have really been taken advantage of, especially because of the uptake in AI tools, and it's really time for us to take back that space.
Well, there we have it. That is the next generation of security from Cisco Hypershield. Thank you so much for joining us today. It's been a real pleasure.
Thank you so much, Tamsin, for having me.